Good morning, one and all. This is A.S.M. Raju from Mechanical Department from Chevrolet Engineering College. Today, in the Mechatronics subject, I would like to deal with respect to a topic control systems and what is meant by control system and how many types of control systems are existing indeed to monitor different types of mechatronics systems and even the subsystems monitored, the power supply to the n number of sensors that have been discussed till the last class, different types of sensors, how they will be getting executed, feedback alignments, and input conditions that are being processed indeed to action that particular sensors, and those control parameters, how they will be monitoring as per the program of instructions, a set of instructions programmed and has been dumped to an microprocessor, and that processor will be installed in the controller, and the controller how it monitors the overall components existing in that particular mechatronic system to be operated as per the design criteria. This is the basic phenomenon of this control systems. Initially looking out the outline of this, what is the major objective of the mechatronic system and the impartation of these control systems? There is the basic objective and introduction related to it, control systems of the and its concept, control systems classification, and how many types it has been subclassified, and furthermost it has been subclassified, and what are the design parameters existing for different types of systems existing. So coming to the point of objective, defining the basic features and configurations of the control systems, and upon the analysis of these control systems, I would like to have a detailed and clear-cut vision regarding this open loop control system and closed loop controlling system, and able to learn the control system applications where it will be utilized, and depending upon the application point of view, which systems will be installed for quick actions or else the delayed actions, and what are the general processes that are being followed in the designing of a control system. We are having what is meant by a control system, a system that provides an output or a response based on the given input to the control system, or else the processor that we'll be calling as processor is one of the component existing in the control system. So the diagrammatically it is clearly showing that input, that is nothing but a desired response, need to be obtained, that is given as an input signal to the control system. And here the control system consists of a processing device comprising of a set of instructions, how the processor will be transferring to an n number of parts or actuators. The actuators will generate the corresponding output and the actual response will be obtained. So this is an basic control system functioning, or the definition of the control system. So here are some of the examples. Here the car itself, it is showing that a sensor that has been placed out here, and upon displacement sensor. So upon visualizing or detecting this car, automatically the sensor will be getting highlighted, and controls the sensor will give the signal to the control system, and that control system will pass the signals to the gate to be lifted up for the movement of the car. So this is an basic application. Hence, whether the gate has been opened or lifted up or not will be sent as a feedback signal again to the control system, and hence it is called as an closed loop control system. So we are having two different types of control systems. One, it is an open loop control system, and another one, it is an closed loop control system. As we have already discussed in the previous class at the introduction of this mechatronic system also. So the main differences between these two control systems, or open loop control system doesn't have the feedback alignment, and closed loop system will have the feedback alignment. So let's be clear regarding this point. Here the sensor is being considering this particular system as an open loop, and I will be explaining initially, and later on I will be explaining the same system as a closed loop system also. Considering the same operation that you are visualizing on the screen as an open loop control system, when the sensor senses the car, it gives the signals to the, or process the input signals to the gate that it has to be opened. But there will not be any feedback to the control system that whether the gate has been opened or not. So it may get opened or may not be get opened, or else fully it may be opened, or only semi or 50% of the gate will be lifted up. So that doesn't matter in the case of open loop control system. But whereas in the closed loop control system, when the sensor senses, it gives the signals to the controller, and hence controller activates the processor, and processor will give the signals to the, or guidance to the actuators to lift that particular gate by switching on the motors. So whether that gate has been opened fully or not, there will be an feedback alignment. So how much it has been opened, or how much that motor has been oriented, whether it has been oriented as per the given set of instructions or not, will be having a particular guidance or monitoring for its opening criteria, and that signal will be sent again fed back to the processor or else the controller, and it will compare with respect to the reference signal given in the set of instructions as per the program. So initially in the input signal, when you have been given to the system, it will be having that the actuator which is connected to the gate should be opened with 90 degrees. So whether it has been opened to the 90 degrees or not, after it after the motor orientation to 90 degrees, a sensor will be highlighting, and it gives the feedback to the controller that the 90 degrees orientation has been done. Whether in the case of open loop, it this process will not be existing. So that is the basic difference between the open loop control system and closed loop control system. Similarly, showing the similar examples, which are the electronic components which are utilizing for paper roll manufacturing and cutting of the paper as per the A4 sizes or A3 sizes, or whatever it may be the input parameters given, and CD-ROM, whether it is being read as per the lenses criteria, sensed or not, and a MEMS application simultaneously, and radar application, which are utilized for defense categorizations, that is weapons, as per the timely basis. The basic definition: combination of components or subsystems that act together to perform a certain objectives. So what are the objectives that we are having, and how far the environmental access is being taken place? and interaction defined in terms of variables. So that will be having the operational criteria. It may be done in an closed conditions or else the open conditions. So most probably in the industrial field, almost all the criteria will be followed as per the open control parameters. So naturally disturbances will be commencing in the operational process also as well. Those are nothing but the environmental disturbances, whether the wind fluctuations may be very much high or temperature that can be offered by a system maybe less when compared to the seasonal variations. That is nothing but in the summer we'll be having an high temperature factors in the environment. So that may defeat the operational conditions of the system installed in the open areas. And the variables, the input conditions that we are giving for the operation of system, simultaneously the system outputs that are being getting, and feedback alignments existing. So an interaction of components forming a system, nothing but components. The components give the signals to the electric to the actuators, actually actuators in four different modes. First one, it is an electrical mode, hydraulic mode of operations, pneumatic mode of operations, and mechanical mode of operations. And when these operations has been given to the systemic device, the mathematical modeling need to be taken place as per the design criteria or dimensional accuracies of each and every component, and an outline view or a block diagram will be getting drafted. So here we are having four different modes of transferring the signals or components actions. First one, it is an electrical. So electrical in the sense will be coming to the as per the ancient criteria. Initially the mechanical mode. So mechanical mode in the sense utilization of driving systems, that is a rope drive system, chain drive system, belt drive system, and even the this particular high velocity ratio, that is chain driving system, and that is being operated with respect to an push button type of system, that is manual mode of operation. And mechanical in the sense manual mode of operations. So here we are having this systems which are operated manually by pressing particular switches or opening a lever type of systems or pedal type of systems or orientation of grills with respect to the hands, etc., that are physically operated manually. Next one, it is now we are coming to the electrical components and full-fledgedly the motors which are being operated with respect to the electrical power supply. And third one, it is a hydraulic source. Hydraulic source in the sense pressurized fluids will be utilized indeed to operate the actuators. Simultaneously, the pneumatic conditions, pressurized air will be utilized to operate the entire actuators. And later on, the mathematical models will be getting drafted depending upon the mode that we have been chosen from these four modes of transformations to the systemic devices need to be operated. So control system. Yeah, the basic difference that you have been already discussed here, that and here it is called as an output transducer or sensor. This is called a feedback loop, and this feedback, by discarding this feedback loop from the output design to the reference channel, this is called a reference channel. So to this reference channel, if this particular system or box does not existing means, hence this overall circuit system is called open loop control system. So by the incorporation of this feedback alignment or output transducer or sensor to the reference channel, this circuit diagram will be called as an closed loop control system. So we'll be having a depth look how the functionality is being taking place in the case of this control system. See here the input or reference signals. So reference here specifies that the standard values that are existing as per our design criteria will be given to the system indeed to monitor the results which are obtaining in the present manufacturing process, and the results that has been obtained presently have to be compared to the standard results already fed to the input transducer through the input transducer. Here it clearly specifies the input signals. So these signals is nothing but will be processing these signals as per the programming criteria set of instructions. So set of instructions is fed with respect to the input transducer, and here it is the reference channel. That reference channel will send those signals to the controller. It's a normal process of operation. And summing junction. So here summing junction, we'll be discussing it in nearest feature. Next one is in process or plant. So indeed to commence any of the operational process. So let us consider the mechanical operating processes. Let it be the either milling process or a drilling process, reaming process, tapering process, whatsoever it may. Considering a milling process in the sense here milling operation. Milling operation is being progressed in the case of this processor plant, and moving on to the generating the output. So after performing this milling operation, the design criteria or the reference output has been achieved to the object or not. For example, I need to get the object in the milling process after commencing the milling process, as length is equal to 2.5 mm and the breadth is equal to 2.6 mm and the depth is equal to 2.6 mm. So if those criteria hasn't got, here there will be an inspection category coming from here the inspection process. After commencing the process, the inspecting element will detect whether the given reference channel or as per the input criteria design parameters, the reference with the reference characterizations, the results has been obtained or not. So these results will be verified here, and those results will be fed back by a transducer or a sensor to the reference channel. And here the comparison will be taking place with respect to the reference and obtained results as a feedback. So if there is any further modifications, those errors will be identified. For example, you need to get the breadth as in 2.6 and length and depth has been satisfied as per the input or reference values, and we have to monitor only that particular breadth. So depending upon breadth, what it has to be progressed, how much it has to be progressed. We have got the error that 0.02 mm, and that need to be compensated, and only that particular set of instruction will be highlighted with the help of this controller. Only that instructions will be executed by this controller to the uh, process or plant, and that summing process of instructions only here will be added. So again the component will be placed on the machinery, and here the process will be getting progressed, and that error 0.02 will be compensated by removing or working out on that particular object. And hence upon completion of that process, again the inspection technology will be getting progressed at this unit, and will the results will be again fed back to the here that is reference channel. So when the obtained results are being satisfied with respect to this input or reference channel, hence that particular object will be getting okay and output within control variables. So this is the operational phenomenon of a closed loop control system. So here are we'll be having a look, just we'll be having a brief look about this. Just we have whatever we have discussed, it will be in an theoretical basis. Input is nothing but the desired response, output actual response. Control variables, conditions are measured and controlled normally in the output. Manipulated variable, that is compensation activities will be existing over there. And disturbances, signals that may affect the value of output. So if there is another environmental impacts on that machinery, nominally will be having a small minute errors. That errors need to be compensated upon the uh, summation junction or point, indeed to addition or subtraction of the signals. So if as per the environmental conditions, if signal strength is very much high, we'll be limiting the voltage factor at the controller, and simultaneously if the voltage levels that has to be provided for the systemic device is very much low, then we'll be indicating or authenticating an generator for increasing or rectification process, or increasing the resistance limitations to increase the voltage levels and need to operate as per the criteria need to be obtained. So the control systems are basically open loop and closed loop. Yeah, open loop system. Here with respect to an actuator conditions, actuator is nothing but here motor. So with this, we'll be having a glance look. Indeed, to work out with respect to this is an block diagram and an example over here. You have already known that there is a no feedback. Look at here in the circuit diagram, or this flow chart diagram. We doesn't have any feedback alignment here. Feedback alignment after load. There is no any feedback containing and reference channels, etc. for this operational process. Just input signal as per the programmable basis it is giving, and controller will guide the operation element to condense the proper actions by the actuator, and those will pass on to the load conditions, and the certain gates will be progressed or produced, connected over there, indeed to perform the required task at the output region. So here positive and negative voltages, we are having input signal that is a low signal, and it will be increasing or else decreasing as per the criteria that has been provided. So power supply will be given power, and motor will be getting rotated, and that rotor will be utilized indeed to distribute the signals to from the antenna at a particular frequency levels. So there is a design parameter or input that antenna should propagate the uh, 12 megahertz of frequency signals to the environment, but we doesn't know that whether it is providing 12 or distributing 12 megahertz of frequency signals to the environment or not, because there is no any feedback alignment at the output region indeed to monitor it. So hence we have to assume that it is being transferred that 12 megahertz of frequency to the environment, that is signals transformations. All right. So load conditions is clearly cutly displays. Controller is nothing but the amplifier, actuators are nothing but the motors and connecting the gears to the output signals and load parameters. All right. Next, moving on with respect to an closed loop control system. Yeah, we are already aware of this particular circuit diagram providing the input signal or reference signal. This is an error rectifier or comparator existing here, and controller, output alignment, load providing, and here there is an inspection device or capturing device, and feedback alignment that provides the measured signal at the output to the reference unit, and here the reference unit will compare the signals to standard values to with respect to the obtained values, and if it has been satisfied as per the design criteria, it will be executed for the distribution process. So similarly we'll be having a glance over here. So here there is an input, that is voltage input. How much voltage has to be provided? For example, 50 volts 60 volts. Depending upon that, the armature reading or resistance providing at the potentiometer will be taking place. As per the RPM need to be obtained at the output, here the error signal is being existing, and controller will give the signals to an amplifier, need to amplify the signals or electrical signals that are being passed from the controller, and those electrical signals which are necessary to actuate the motor at that particular capacity as per the input criteria. The input conditions, in the input conditions we are given that the motor has to rotate with 300 rpm. So indeed, to satisfy that 300 rpm, input conditions need to be maintained that only at 10 or 20 20 amperes or 30 amperes of current need to be provided. So that need to be maintained. So if the rpm rotations per minute has been decreased, simultaneously this voltage levels will be getting varied. So incrementing of the electrical or emf or voltage levels at the input level satisfies the or any rectify or reschedule the control parameters by the controller and amplifier, and provides the highest voltage to the motor indeed to increase the speed. So that speed, whether it has been increased or not, will be obtained as an or will be verified with respect to the inspecting device. Here the inspecting device may be of the tachometer. The tachometer will be connected to the motor shaft, and that will give a feedback signal to the error. So input condition here it is, the motor rotation need to be maintained at 300 rpm. Just we'll be having a glance of live example here. We are almost we are aware of driving our automobile, that is bike. So indeed, to increase the speed, we will be increasing our potentiometer with our right hand, that is accelerometer, increasing of accelerating. So here the increment of the acceleration is now displayed with respect to the input potentiometer. So acceleration increasing or voltage levels are increasing. Simultaneously controller. So controller is nothing but here the engine performance. So consumption of a fuel will be increased, and depending upon that operational sector will be getting increased, and the stroke limitations or stroke length or number of times stroke variations will also be increased furtherly. So amplifiers. So obtained current at the output level, that is high large heat produced within the engine will be circulated indeed to transfer the motor. So engine here, high amount of heat will be converted into the mechanical action. So that is an engine. So that actions will be furtherly done within less time period. So within the less time period, number of strokes will be increased. Depending upon that, the motor rotations will be getting increased. That motor will be connecting with respect to the shafts to the chain drive system, and the chain drive system is being drive that back wheel. So this is the basic phenomenon as we have generally or practically we are experiencing in our daily life. Coming to the advantages and disadvantages of this open loop control system. And in the open loop control system, stability not a major problem, because we doesn't know that whether the input conditions has been satisfied or not. So it is very much cheap than the closed loop control system, because the components, inspecting components in the closed loop control system plays a high economical ratio factor. High economical factor. It can be used even if output cannot be measured. So output may be varied or may not be varied, or may be obtained to an certain level or may not be obtained to a certain level, and it is very much easy to maintain. So disadvantages: changes in the system or disturbances cause the errors. That is nothing but environmental factors that leads to decrement of the voltage if the system has been given upon its own authentication or operational levels, then there will be an output error also. So certain input conditions that you have been programmed may not be obtained at the output range. So no longer accurate when system is disturbed. So when the system by this we will not get the exact results. That's the main intentionality. Obtaining the low bandwidth or slow response when compared to the closed loop control system, slow response will be obtained and it will be delayed in generating the results. Whereas those conditions or those limitations in the open loop control system will be rectified in the case of this closed loop control system. Coming to the advantages, reduced sensitivity to the disturbances, inputs, and parameters changes when compared to the open loop control system when compared to the can change the system dynamics speed of response and accuracy will be maintaining because these and all are the factors: accurate results generation, accuracy, reduction of the effects, and reducing of the non-linearity functions and stabilizing the characterizations. These and all are the additional advantages happening because of the installation of this feedback to the systemic device, and hence this feedback that is uh, giving the signals by sensing the parameters that are progressing with respect to the criteria, and these as per the signals that has been passed by these sensors, the modifications as per the required criteria at the comparator are being progressed and reinitiating or remodifying the entire processing set of instructions in the processor that are guided from the controller. So by this, we are obtaining the fast response with a high bandwidth. So even though we are having some of the limitations, if these modifications are being occurring, there is nothing but it is very much cost effective. That is economical as commencing the economical factor. Its cost is very much high, and it is a more complex in operation. And only the skill, it specifies that only the skillful worker can monitor these situations or can monitor the or operate this particular kind of systems. Risk of instability or there is a risk of instability, and that can be compensated only to a particular extent with the high functionality sources done. And even though indeed to commence that high functionality sources, again the economical factors will be getting increased. So indeed to impart the skillful worker, there will be a demand for that skillful worker in the economical point of view. So those are the major limitations in the case of this closed loop control system. So feedback and its effect. So what is meant by feedback and how it gets affected in the case of two systems that have been discussed presently, and what are the additional parameters that we are getting than the open loop control system to closed loop control system by the incorporation of or by the impartation of these feedback systems. So it is a system which maintains the relationship between output to the reference channel as we have discussed earlierly, and it is the basic phenomena when the output has been monitored and given to a reference channel, the error which has been generated at the output will be minuted as per the modifications done from the controller to the processor. So hence the actions will be getting passed away, quick actions will be getting passed, and depending upon that quick actions, you are getting an ultimate results or modifications but for the decrementing of errors that has been generated. So, but we have a point. Feedback has effects on performance characteristics also, because stability will not be maintained, because always the modifications are encouraged here. If the feedback signal has been came into the force, so that an error need to be specified and a regular process need to be in an halting position, and for that the stability will not be maintained, and overall gain will be very much less, and external disturbances creates some of the noise signals, and these are some of the feedback and its effects. Moving on to the feedback and its effects, response curves will be getting generated. So within the limitations here, the time factor specifies in the x-axis direction, and the response obtained at the output channel noted on the y-axis. And let us take an example that this is the reference zone of line, which has been acceptable region for maximum differences or output gain, maximum output gain. But over exceeding that will initiates that output with high gain. It has been pictorially represented over here with respect to an output with a high gain than the reference channel, and this is an input frequency given, and output with an low gain, that is beyond the limitations the output is being maintained. So here it has been neutralized or stabilized to some extent as per the input criteria. So these are the basic, and this is the basic outcome that has been monitored on the oscilloscope at the monitoring actions. Control systems classification, how many times it has been, how in what ways, and what application basis and what parameters of operations it has been classified. We will be having a simple look. CISO, a single input and single output, nothing but the open loop control system. And the MIMO, multiple input and multiple outputs, nothing but modifications as per the feedback. Number of programs will be taken place, and errors, and for the rectification of those errors, the changes or modifications that are being executed within the installed program. That is nothing but MIMO. Next, linear mode of operations and non-linear mode of operations, depending upon the time basis, time variant and the time invariant. So by taking in standard timings for 5 minutes, 10 minutes, 15 minutes, invariant timings, and time variant for 2.5, 3.5, considering of float values and different timings as per the operational basis, time variations will be existing, and analog kind of display, particularly coming to the display point of view, analog kind of display and digital kind of display. And next one, it is kind of a process that need to be taken place in the operational sector, and depending upon the time, depending upon the process or kind of process will be having control, that is process control. And sequential control, a series mode of operation, the sequence mode of control need to be taken place. And we have there is an design steps for a control system. Basically there are six different steps or existing. First one is determination of a physical system and specifications from the requirements. So the standard requirements will be monitored here, and that will be taken into the force, and that will be given to the systemic, giving as an systemic input considerations. So these considerations, upon these input considerations, Step 2 will be getting availed. So drawing of a detailed layout of physical system. So in what dimensional criteria entire the setup need to be maintained, and initially what need to be drafted, and next processing actions and steps to be taken place, and operational criteria after completing what the action and performance need to be taken, etc. will be drafted in the step 2. And moving on to the step 3, transforming the physical system into a schematic system. So transforming the physical system. So physical system in the sense nominally operating with respect to a live basis or manual operations. When the program has been given, it will be drafted by one particular skillful worker and